Good morning, students. Today, I like to start the concept of compiler construction of Unit 1. So, as I already taken a class on the introduction, that is how the course outcomes, and also I discussed the syllabus of this subject. Well, today I'm going to start you the concept of compiler construction and also a concept of unit 1. So if you see this one today, this is how something the basics of compiler construction. So before actually studying on the concepts such as the different phases of compiler, first we will learn regarding an introduction on compiler. So the first concept of compiler construction is on the basics. So as you people already might aware of that what is a compiler, right? So this compiler is something, a software, a computer program. It means it can be a software. It is a software which actually translates a one language into another form of language. That form of language where it converts will be understandable for machine. So this basically is a software, is a complex program. Why I am using the term complex program here? Because the number of lines of codes which is required for compiler to have a new compiler is in a large number. You can see there are the lines of codes which is required for compiler is much more. As you know that if the number of lines of codes are more, that means the complexity get increases. So that's why we can term it as a complex program. So that's why we are learning into phase by phase. So as I said you that compiler is not just a single thing. Of course it's a software you can, but it is a combination of much more different things. So we'll be learning all of these concepts in each unit so that at the end of this course or at the end of this subject you will be get to know that what are the different phases of compiler, how they works, and practically you can build a compiler in your desired language. Now if you see that compiler actually, why the compiler is required? As you people might already aware of that, the compiler is what a translator. It means it just translates a language, one language into another. But along with that, it acts as like an interface mechanism. Interfacing mechanism is something like here, as you, as we as a user, when we want to communicate with a computer, we doesn't the what we know have to communicate to the computer. Also, we may require to get the information from the computer which we can't understand in our language. So that is how it acts as an interfacing one. Also, it acts like as a command interpreters. Okay, so this interpreters is something as like as compiler, but there is a difference. So anyhow, we'll be learning about interpreter as well. So if you see the diagram here, if you see this diagram, this is how your source program, and with using of this compiler, you are achieving target program. So this target program is your machine understandable format, or the code which it will be in the form of registers. So that is how that's the basic of compiler. But now in this first chapter of your unit 1, we'll be discussing why we need compilers, a big history of compilers. We'll be learning also what are the things which are related to compiler, that means what are the softwares programs which are related with compilers. Also we'll be learning the translation process. That means what are the phases will be required in order to perform translation process through compiler. Also we have to see now the data structures, that means what it supports in order to do compilation process. So that's why, so this is why compilers we need, why we need a compiler, also the reasons for having compilers. The second is what, as I said you, the programs which are related with compilers, translation process. This translation process requires the phases of compiler, and the data structures, which is basically a combination of symbol table, and what are the issues in compiler structures we need to see, and there is a process called bootstrapping and porting. So this process also been covered in this chapter of first unit. Now going to the first topic, that why we need compilers. So compiler, basically why we need is, let us, if you don't have a compiler, previously when there was no compiler, so there was a process to write the code in machine language. The problem in that process is it is time consuming process and it is very tedious process. Why? It is because anyhow this is machine understandable form, and it is very difficult for a user to write the code in that language. Only if you are writing simple program, then it's okay, but when you go with the complex codes, then it is very difficult for us. That means, the amount of time in order to write just a simple code also requires more time. So because of that, they thought to have an alternate, that why can't we have an alternate in such a way that we can build the things in a way that we can understand, and there should be a process by which what we have written in our form should be understandable to machine by a software. So because of that, the compiler necessity arises. But still, like, they haven't achieved the task what they are desired for. Then after machine language, so this is first initially they worked on, then later they started working on assembly language. So assembly language also, it's not so, it's not so easy. Why? Because there are some defects, the problems in that. Still, like, it is not completely human understandable language, because the terms which will be used in assembly language are in symbols. So it finds very difficult for us even after, but of course it has some improvement over machine language. But what we required as a user has not yet achieved through assembly language. That means the purpose of getting the simplicity or to reduce the complexity in the previous version has not yet decreased as what we expected. So that is why after assembly language they started to work on compilers. So the first compiler which was developed in the year 1954 and 1957, between that era it has been developed. So the Fortran language and its compiler, who has developed that? IBM lead by John Backus. This is the person who actually work on natural languages, who actually work on grammars, because here previously they haven't started directly working on compiler, but they started working in a phases by phases. Let us, you can see that the structure of natural language, because they need to know that what this natural language is, for that how the structure will be there, because Noam Chomsky has studied the structure at the same time, and because of that they came up with some changes in that, that is Chomsky hierarchy. In that he has classified the language, that means that he has studied on the language property and he has finally worked on the classification of language, and based on that the parsing problems was pursued. Parsing problem is to whatever the language what we have, they worked on that. That's why they worked on context free language and parsing algorithms. That means, you know, parsing is something like you are working on the grammar of a language. So they work on that because they want to know that what is how, because what the machine understand the language and what we human used to communicate are different. So they are working on the thing where this form should be get converted into the machine format. So they are working deeply on that. So that's why they are working on the grammar of a language first. Initially what they did is they worked on grammar of the language. That's why they started on parsing process. So they already like working on the problem which arises through parsing. So that's why they worked on context free language and the related parsing algorithms. So this was actually happened in the year between 1960s to 1970s. That means all the algorithms which are related to this one are the theories which are actually required, such as on automation, finite automation or regular expressions. They started working on that only. So that's why what they have decided is that for any programming language, in order to express them, so what they did is they made that language, they made that each line of code into a set of symbols. Whatever we have given a language, for every language is a set of tokens, a set of symbols. So that symbols they are being using in order to express the structure of that language. Using that symbols, they worked on regular expressions. So this is how on finite automata they started working on that. So because of that what happened is they have developed for working on efficient object code, because ultimately their was goal is to have an object code. An object code is something which a computer understands, and they want to have an object code for the given grammar. So that's why they also started working on some techniques how they can improve the code. That means improving the code means a lot. Improving the code means decreasing the number of lines of codes. So here optimization techniques plays a major role. Optimization techniques means improving, decreasing the number of lines of codes and replacing the appropriate addressing modes. Because of a proper and an efficient addressing mode, the execution of that code will improve. So that's why they have implemented the techniques how they can improve the code in terms of the efficiency, in terms of the speed, and having the less number of lines of codes. So that is how they started working on that. So that's why the program, the software, whatever they have developed, they developed to automate the compiler development. So that's why I said you that compiler is just not achieved through a single task. They have worked on the phases by phases. Like they were started for development of parsing process. So that's why they started working of parser generator. Okay, and so for that, like parser generator works on YARC, that is yet another compiler by a person called Johnson. So started initially for Unix system. And not only for this one, mostly most of the applications are being developed through Unix only. Even they learn, even the C language also they developed through first Unix only. So that was happened in the year 1975. Parser generator and scanner generator. So if you see scanner generator, so scanner generator means here it is how lexical analysis phase, okay, as you might aware already about that. Lexical analysis phase means grouping that, that means the lines of code is there. For example, one line of code is there and you are making the line of code into group of tokens is group of lexemes. So that is the role of scanner generator. So for that they have developed lex, okay, and for parser generator they have developed yak, and lex has been developed by mac lex, again for the same Unix operating system, okay. So at the same time only, so scanner generator, they worked on scanner generator as well as they work on parser gen. Parser generator means whatever the tokens, whatever you have achieved through the language of a program, they are working on the grammar of the language. That means how can they develop, how can they get the parse trees. So that's why this parser generator is also one of the phase, and also scanner generator, that is lexical analysis phase. After that they most focused on the automation only, that how this see automation means here the compiler should do all this process, not as a human being. So that's why they are actually working that, okay, these are the process, but we need to automate the process so that within less amount of time you can get the large output. So that's why code generation was undertaken again in the year 70s and early 1980s. But at that time the success was not that much as we expect, okay, but still they have started, they are working on that. And recently whatever the advances that has happened in compiler design, such as they were started developing on some built on algorithms, sophisticated algorithms, and that algorithms like your unification algorithm from Hindley Milner type checking. Type checking means, you know, that for example you have taken one expression and that expression whether it is having the same data type or not, so that type checking process is that, so that algorithm can use to check the type compatibility. Also there are now many IDEs, that is integrated development environments, which are Windows based actually, and that have all the process such as editors, linkers, debuggers and project managers. So because these are the programs which are related to the compiler as well. So this basically they work on this one. So now this IDE is helpful us to decrease the task to perform, and even from the last so many years the purpose and the basics of compiler design have not yet changed. The purpose is the same, to get a translated code. The purpose was the same, but the improvements was they have did well. They have the execution speed has been increases over time period of this many years. So the purpose has not yet changed, okay, that means the basics on that. So this is about the history of compiler and also why we need a compiler. Now going to the next topic, that programs, that means what are the softwares which are related with compiler. So you know interpreter is also as like as compiler, interpreter is also a translator. But there is a difference between interpreter and compiler, as you people are already might aware of this, that here what happens in interpreter is instead of generating object code, it simply execute the code. See, in compiler the source code will converts into object code. In compiler the source code converts into object code, but here It don't generate object code. It simply execute the source program. Okay. In compiler what happens? Source code to object code, then object code, then after that it executes. But in interpreter it just directly execute the program without having an object code. So you can have many languages which it supports, such as basic is a language, LISP, and so all of this might be used, or they are using in educational or any development situations. Might be they are using in companies. Earlier they were using much more, but now might it are not using. Based on the projects, the conditions of using such languages is required. But nowadays there are many languages which are being using by companies which supports interpreter concepts. Okay. But the problem in interpreter is like the execution speed is very less while you compare with the compiler. Why? Because here in the interpreter what happens is it interprets the code line by line. For example, if there are 10 lines of codes are there, so interpreter will interpret checks line by line, but compiler will compile it at the same time all of the 10 lines at once. So that's why the speed of execution is less while you compare with compiler. And so similarity, it has a similarity because it has a it is also a translator, but there is a differences as well. So this is about interpreter. Next is assembler. Assembler is also a translator, but assembler is something like it just converts for the assembly language. So assembly language, as you people are already aware that what is assembly language, it's just like a symbolic form of language, a one machine language only. But just the difference between, if you say the difference between machine language and assembly language is that machine language have just machine code, but assembly language along with that machine code it has some special symbols. That's why you can find the difference in between assembly language and machine language. And a compiler may generate assembly language as a target language. Okay. So compiler usually converts into object code. So object code can be an assembly code or else it can be a machine code. Assembly code is as like as machine, but you may find it can generate assembly language as well. But an assembler finishes the translation into object code. So assembler will convert assembly language into object code, and compiler can have high level language to assembly language or else machine language. Okay. So either interpreter or assembler or compiler, all of these are translators. Next is about linker. So linker is something like whenever you have an object file, so that object file, so it collects all the separate which are object files are there, and that it will make them to directly execute that file. See, object file is a different thing and executable file is a different thing. Object file is your machine file, machine understandable file, and executable file is something which already runs, which executes. So this linker will connect all that object files, so that what happens, why it connects, why it links, so that it can execute that. So can it have an executable file. So that connection of object program to the code, how it connects through library functions. If you go with C language, you may find this, that there are many library functions are there, that are standard library functions, and this library functions are being useful in order to connect all of the object programs excuse me, so that this all together object program will get a resource to the operating system, because ultimately the executable file will be executed in a particular operating system. Also, like the it has also depends on the operating system and processor that how this works. So this is about the linker. Next, if you go loader, see loader is something like linker will communicate all of those object file which they receive through compiler so that it can execute. But in order to execute that, they require a memory. That means they require a memory address in computer. See, having the data in the computer is different thing and executing the data in a computer is a different thing. So having the program in the computer is for storage purpose, and executing the program in through computer also requires a space. I mean memory. If it requires memory means it requires memory address. So whatever the addresses which are required, memory address which are required, so it relocates such addresses so that the files which are to be executing, which are should be in executing mode should be get executed. That means it relocates such addresses which are given to a base address, so that a continuous memory allocation will happens, in that the complete file will be executed. It means in simple term we can say that the executable code will become more flexible because of loader. Because loader make the environment friendly for an executable code to execute the code. So that's why it can often recognized as a part of operating environment. It won't be actually considered as a separate program, because here I have said you that is one of the program which is related to compiler. You may not actually should call as a separate program, but you can call as a supporting program for operating environment, because this is how something where a program executes, operates. So that's why it as a supporting program for the operating system to operate that code in that environment. So that's why you can consider as a supporting program, not as a separate program. Program means here a software. Next, if you go with preprocessor, so preprocessors are something like some other files which are being used explicitly. If you want to go with some of the extra properties, if you want to include some extra properties in a program so that it should perform the task which we expect to a program, so it can be performed by substituting other files in the given program. That means additionally you are adding some of the files, like you can have a preprocessor, you can also call as micros. Like in C language you may have, like here you can say hash define, right? So this is how the macro, right? So this also preprocessor, because anything which we consider as a hash symbol are called as preprocessor. So if when and then if any kind of such facilities are required by a language, then this preprocessor will helpful to that language in order to give some additional features in order to execute the program in a desired way, how we are expecting to be the program should be get executed. Okay, so that's why that are called as preprocessed. That means pre-processed. The pre-processed means already that have been processed. Only is the thing is that you need to take them in order to execute the specific property which is available for that preprocessor in that program. In order to include such facility, we are using preprocessor. You can call as add-ons. Okay, you can call as an add-ons that adds some extra features to the given program. Next, if you go with editors, editors are also something you can have IDEs, right, which are integrated development environments. So that also been a part of editors. So these editors are actually the purpose of these editors here is because of IDEs, editors will be very much interactive. It helpful us to inform about some errors that are syntax errors especially, right? So for example, if you go in IDEs, if you are writing a program, if there is a problem in that while writing the program, so it will help us, the IDE will help us in a way that it is informing some kind of errors that you shouldn't take in such kind. That means the thing is that it is adding an advantage for us in order to write the code easily. So that the actual operation of compiler see here, there is a role of compiler called grammar checking. What is that? Grammar checking. So this grammar checking means here syntax analysis, right? So this syntax analysis phase, that means, for example, whatever the grammar, whichever you have written, grammar means how the code, whatever you have written, editor will take some of the task of compiler at the time when you write the code. So something like editor is helpful for compiler to reduce its task. Okay, so that's why it is like something an interactive based environment where you can have like at the time of writing the code only you will be able to get that error, that okay, this kind of error can be there, so we should avoid such kind of errors while writing the code, so that the task of compiler get easy or it becomes easier. Now the next thing is debugger. Debugger is determining the execution error in a compiled program. Okay, so here also it is some of the task of compiler it used to do. That means it just tell us that execution error while executing a program, it determine the errors in a compiled program. Compiled program is the compiler part will convert after that when it executes. So compilation process is a different thing and execution process is a different thing. So as and when the compilation process gets successful, so this execution error, if there are any execution errors, so that determination of such kind of errors will be done by debuggers. So what it does here is that it keeps tracks of most or all the source code information, so that the task of performing the debugging process becomes easier. Also, there is a concept called breakpoints. So this breakpoints means whenever it checks for any errors, it halts its execution at some locations. So whenever it halts the execution at some location that are pre-specified locations, at that locations it halt execution. So such location are called as breakpoints. So through these breakpoints, it is easy for us to know, to track that what kind of error at particular point we got, so that we can rectify such kind of things. So this breakpoint is an added advantage for a user to get to know that where exactly the problem arises. Also, it will be supplied with some information. So the last point is something which it will give you some appropriate symbolic information by the compiler, because in compiler you may have symbol table, so that symbol table will help us to give the symbolic information. So this is how debugger is also related with the that means debugger is related with the compiler. Next is profiles. So this profiles basically works in IDEs. What happens here is it just collects the information on the behavior of object program. Whenever a program executes, how it executes, the behavior, the pattern on which, so it collects all those patterns, behavior patterns of the programs when at the time of execution. So this, because of that, what happens, it will what is the advantage here is, it will give you the call times for each procedures. This amount of time is required for each procedure, means each functions in a program. That for example, if you may have 3 or 4 procedures, based on each procedure the amount of time is required will be determined by the behavior of the program. And also it will let you know the percentage of execution time, how much time is required in order to execute the code. So because of that, it can helpful us to improve the execution speed, because if you know that the problem where it arises, that it is taking much more time on particular thing in order to execute, so we can improve the task, we can avoid such conditions, so that the execution speed of the program improves. Not only that, we have project managers. So project managers are actually version based programs, version control based programs. For example, whenever you are developing a program or a software, you may are working with different versions. So this project manager programs are actually such kind of version based programs that will track us to go to all the previous version of the particular software. So because of that, what happens is you will track the previous versions, so that you may get it will be helpful us to have the coherent version of a program. That means in order to maintain such kind of stability in a program version, in order to maintain the stability in a version program, this project manager will be helpful. Because as and when if we have the track record of the previous versions of any software programs, so that will be very much helpful for us in order to maintain the coherent property of the program. So that's why in Unix you have source code control system. This is also one version based or version control based application, software, which controls that. Also we have revision control system. So this project manager also helpful for you can say that are relevant with the compiler. So this is about project manager. The next is about translation process. So this project manager oils, profiles, debuggers, editors, preprocessors, loaders, linkers, assemblers, interpreters are all the programs which are related with the compiler. Next, if you go with the next concept, is about the translation process, which is the actual process that on which we are working. We will be having all of the remaining syllabus for this process only. So if you go with the compiler phases, basically we have 6 phases, and we have some auxiliary components also, but we will see what are the 6 phases. So the 6 phases is, the first phase is here scanner. This is what the scanner. Next is about parser. Scanner means here you can call as lexical analysis phase, okay, and parser is your syntax analysis, okay, and the next one is semantic analyzer, which is used to check the meaning, which is used to retrieve the meaning from the given line of code. The next thing is that how can you optimize the code. As I said you that source code optimization doesn't mean just to reduce the code, but also to increase the efficiency of the code, also to increase the speed of the code. And also the next is code generator. which help us to generate the code. Okay, and the last is target code optimizer. So the target code which you have generated from the previous code, it is used to optimize it further. So this is about the 6 phases, and also it is related with some components such as literal tables, symbol tables and error handlers. So anyhow we will be seeing now. If you see this diagram, you will come to know that whenever, see here, the compiler is source code to target code. Okay, this is your final code, but the source code, for example, this is your machine your high level language code. Now this scanner, so what is this scanner? Scanner, as I said you, okay, scanner means it scans the code and it converts into set of tokens. So here it will give you a set of tokens, okay, that are called as lexemes. Okay, so this lexemes will be given to the parser in order to generate the syntax tree. So it works on the grammar. Parser will works on the grammar. It will give you syntax tree, and this syntax tree will be taken as an input for semantic analyzer, which checks the meaning of a code. So meaning of a code, and in this meaning of the code it will give you annotated tree. I'll let you know what is that. So that the source code optimizer, here it will be using source code optimizer, so that the given source code should be optimized, and using the intermediate code and using the techniques of intermediate code, it converts into code generator. Okay, so this is what your machine code or else assembly code. And again this machine or assembly code should be optimized by optimizer. Okay, so finally you will be achieving the target code, but along with that we may have literal table, symbol table and error handler. Literal table means all the literals which are present in the grammar in the given source code will be stored in the literal table, and the symbol table is to store the data structure, okay, of the given code, and it will be communicating with all of the phases of the compiler. Also our error handler, if any error comes here, so this error handler will resolve that issue and it will communicate directly with that phase. Okay, so it is in something bidirectional process. So in this way the phases of compilers will be there. Now if you go with the each phase in detail, the first you may find as lexical analysis phase. So lexical analysis phase, or you can call as scanner. Okay, so scanner is also called as lexical analysis phase. So what is this lexical analysis phase means? It collects the sequence of characters. So that means that whenever you have given a line of code, for example, if you take this example as a of index is equal to 4 plus 2, this is one expression, okay, an assignment expression actually here. So this is your code, for example. Now what is the role of scanner is here is it separates all the tokens and it forms a group of tokens, such as if you take a, what is a? Identifier, right? After that is left bracket, okay. Next is index, index is again identifier. Next is right bracket. Next here it is assignment operator. Next, what is that? Number. Okay, number, because here we are not taking variable, right? Directly we are taking constant. So constant means here number. Next here is plus sign. Okay, next here again it is number. So this group of tokens will be your lexical analysis phase. This is the process. This is just for a simple example I have taken. So it can have multiple statements also. So like that, for every lines it first separates the line of code into set of tokens. So all of this is called as set of tokens. So this is about scanner process. This is lexical. Next is, you have given tokens. Now you have this given a token to the parser. So syntax analysis phase. Parser means syntax analysis. So checking the grammar, determining the structure or else grammar. So structure here means working on grammar of the program. So how you are doing? So you are making the given set of tokens into parse trees or else syntax tree. Okay, so now we will be seeing how this will happen. First we will be seeing what is parse trees. So here parse tree means generally there is one grammar specified set of grammar will be given, and we need to verify that whether the property of that grammar is satisfying the given expression or not. Okay, like you may have expression. This is your expression. So expression means assignment expression. This is one grammar, right? Then again, or expression is equal to expression. Okay, or else expression is equal to subscript expression. Okay, or else what is that? Additive expression. So for example, this is your grammar. So using this grammar, whether your given example is satisfying the given grammar or not, we have to check here. Also, if there is an expression, again expression can be, if you go with subscript expression, again expression, or else in bracket the expression, again it will be an identifier. So such kind of, this is how the set of grammars rules will be there. So these are what the grammar rules. So we need to see whether our given example, so for example this example a of index is equal to 4 plus 2 is satisfying the given grammar rule or not. If it is satisfying, that means it is syntactically correct. If it is generating a valid parse tree, that means it is syntactically correct. Okay, so this is parse tree, and next is about syntax tree. So syntax tree and parse tree, some of the differences are there. If you see this one here, directly here it is syntax. If you compare parse tree and syntax tree, you can find that in parse tree large number of grammar rules are more, but in syntax tree it is less. That means it is you have less number of steps in syntax tree while you compare with parse trees. So if you see in syntax tree, you just have assignment expression which can rise to subscript expression or else additive expression. So as you know, 4 plus 2 both are numbers, so number and a of index. So index is also an identifier, a is also an identifier. So in that way syntax tree works or else parse tree works. So this, both of these are part of parser. What is that? Syntax analysis phase. Next phase is about semantic analyzer. Semantic analyzer means checking the meaning of the given grammar. Whether, see, the first syntax analyzer means the grammar is correct or not. The semantic analyzer means whether whatever the grammar you have taken, is it giving a proper logical meaning to the given by the given expression or not. Are there is there any task is achieving through the given grammar or not? That is we have to see here. Also, it checks the meaning. Along with that, it will determine some of the runtime behaviors before execution. This runtime behavior means it is executing valid thing or not. So how it verifies? For example, if you go in static semantics, it will concentrate on the declaration part and also the type checking. Type checking means here, for example, you have taken the left hand side and right hand side should have a compatible data type. Okay, so that's why we are using the concept of attributes here. Attributes are some of the extra information or the property which will be provided by semantic analyzer for the given syntax tree. So we have achieved the given syntax tree. Now what is the role of semantic analyzer means? It will convert this syntax tree into annotated syntax tree. Annotated syntax tree means along with the grammar, it will give you the useful information. For example, if you see here, subscript expression, it is given subscript expression and additive expression. But here, what is added, one more thing here is, it is an integer subscript expression which is giving an integer value. Also, additive expression is also giving an integer value. This is one information. Also, here identifier A, identifier index and number 4 and number 2 has been given. And if you see A, what is A actually? It gives an extra information that A is an array of integer. What is index? Index is actually stores the integer value. What is 4? 4 is an integer value. What is 2? 2 is an integer value. So this extra information which gives you the meaning on that is called as annotated syntax tree. Annotations will be provided to the given syntax tree in semantic analyzer. The next phase is about source code optimizer. Source code optimizer means, see, I said you optimization doesn't means to reduce the code. It will be using on annotated tree. Okay, what is it is using? So the input of the source code optimizer is annotated tree, that is annotated syntax tree. On that it is working, and it can work the process of, very important this process, constant folding. Constant folding means here, for example, A of index is equal to 4 plus 2. Now 4 is also an integer and 2 is also an integer. So directly it adds the value 4 plus 2 6 and it will give you as A of index as 6. So you are folding the values which have the same type. Okay, that is constant folding. And also it can use intermediate code. So what are intermediate code you are using? Here you are using 3 address code and P code. So this code will be used on the given annotated tree. So how it works here is, for example, if you take annotated tree, this is the annotated tree which you have got from the semantic analyzer. Now what you are doing here is, this part is excess part 4 and 2. Now what we are doing here is, we are making into single number and we are directly assigning to that assign expression. So that means here we are removing this part and here we are taking only one integer, one number. So directly it is communicating with this one. Okay, so that's why you can see here, this is how the optimization works here. If you see in the lines of codes that, like here you have taken a temporary variable t which is equal to 4 plus 2. Now first this t will be assigned into A of index. Now t is what? storing the value 4 plus 2 means now t becomes 6. So this 6 again assigns here. So finally what you achieve here is a of index is equal to 6. So this is how you have optimized the code. Now the next thing is about the second thing is code generation. Here we have taken what the regular code only, but we have optimized the code. Now we have taken this code for generating the code. So it takes the intermediate code and generates code for target machine. Okay. So how it is doing here is, it is performing that means it is using that statement and it is converting to target machine. Like if you see here, this is here using special symbols that are assembly language. This is an example here. So the a of index is equal to 6. If you go a of index is equal to 4 plus 2. So here you are using registers. So this registers is used. Register is a memory which is used to store in the computer. So now we are using register R0, R1, right? And we are using some operations. So what are the operations we are using? Move operation, multiplication operation in order to multiply that. Also, as you know, this is an array. A of index is an array. So that's why this array value should be moved into the register R1 by using an symbol called as address of A. And finally R1 and R0, 4 plus 2 will be added here and it will be stored in R1. Okay, and using indirect addressing mode. So all these are what addressing modes we are using indirect addressing mode. So this is your using indirect addressing mode. You are assigning the final value 6 to the register R1. Now finally where it stores in R1. So this is how in the machine format, or else you can in assembly format it performs here, which is code generation. But the next thing again here is target code optimizer. Target code optimizer here is like, this is the code which you have achieved. Okay. Now again the number of instructions are, for example, according to this example here is 5. Now in order to reduce or in order to optimize, we are using target code optimizer. So that's how it is performing here is, the first thing is you are choosing proper addressing mode. How addressing mode choosing proper? For example, instead of multiplication operator, multiplication symbol here in this case, here you are using shift left. What we are using shift left. So because of this shift left, what happens? The addressing mode has been changed. So the addressing mode has been changed to shift left, and this shift left will execute, that means the processing speed will increases. Okay, the processing speed will get increases. And also the instructions replacing means here you can find the instructions which are there in this form and in this form, both are different. So the instructions, number of instructions are changing here, and also the number of instructions are also changing here. Changing means replacing here. So if you see now, wow, it is decreasing. For example, here if you see there are 5 instructions, okay, but here we have been reduced to 3. So redundant elimination is performed over here. So that's why I said you that target code optimization doesn't mean only to reduce the code. It means choosing an appropriate addressing mode in order to increase the speed. Also reducing the number of lines of codes, and so that what happens, finally it eliminates the redundancy from the given code. If you see here, as I said you directly here you are not using, see, firstly add R1 R0 directly here 4 plus 2 it is performed, but directly the value of 6 here will be assigned into an array, because A is an array, so that's why address symbol has been taken. Okay, so address of A of R1 will be performed here. So 6 value direct will be assigned, but here you are assigning 4 plus 2 and the result will be assigned into indirect in addressing mode R1. So this is redundancy also decreases, or you can say simply it is eliminating the redundancy. Instructions also been replaced here. Okay, and the addressing modes also has been changed here. Okay, the instructions are also changed. So this many things has to be performed in target code optimizer. So this is regarding the phases of compilers. So next class will be continuing the session with the next concept of the first unit. By this I'll conclude this class. Thank you.